Next is example 2.23. What we have to do in the following problem is, we have to check whether the following sequences are in AP or not. So what is an AP first? If the common difference between any two consecutive terms are equal, then we call it as an AP. Let us check how it is so. As I told you, to find a common difference, we can use the general term Tn minus 1, which means the first term should be subtracted from the second term and the second term should be subtracted from the third term. If the common difference is equal, then we call it as an AP. Let us do one by one. First, what will we do is, this is term 1, that is first term, second term, third term. Okay, to find the following sequence is an AP or not, let us check it whether the common difference between any two consecutive numbers are equal. First, I am going to use T2 minus T1. T2 value is 2x plus 3 minus T1 value is x plus 2. We will simplify by removing the brackets. 2x plus 3 minus x minus 2. So 2x minus x is x and 3 minus 2 is 1. So we got T2 minus T1 as x plus 1. Next, what we have to do is, we have to subtract second term from the third term, that is T3 minus T2. T3 value is 3x plus 4 minus T2 value is 2x plus 3. We will simplify this. 3x plus 4 minus 2x minus 3. So 3x minus 2x will give me x, 4 minus 3 is 1. So T3 minus T2 we got it as x plus 1, whereas T2 minus T1 is also the same, which is x plus 1. Therefore, the difference between any two consecutive numbers are equal. Therefore, this sequence x plus 2, 2x plus 3, 3x plus 4 are in AP. AP is an arithmetic progression. Since the difference between consecutive numbers are equal. Okay, we will move on to the second subdivision. We follow the same steps what we did in the first subdivision and we will find whether this given sequence is an AP or not. So what we have to do is, T1, this is first term is represented as T1, second term is represented as T2, third term is represented as T3 and fourth term is represented as T4. Let us check one by one. First we have to do is T2 minus T1, that is first term is subtracted from the second term. T2 is 4 minus T1 value is 2, 4 minus 2 is 2. Next, T3 minus T2, T3 value is 8 minus T2 value is 4, whereas 8 minus 4 is 4. So from this itself we can conclude that the following sequence is not AP, because the common difference between any two consecutive numbers are not equal. Between the first two consecutive numbers we got the difference as 2 and the next two numbers we got the difference as 4 and they both are not equal. Therefore, the given sequence 2, 4, 8, 16 are not an arithmetic progression. We will move on to the third subdivision. We follow the same steps to find whether the given sequence is an AP or not. What we have to do? First we have to consider the T1, T2, T1, T2, T3, T4. So first is what we have to do? We have to find T2 minus T1. T2 value is 5 root 2 minus T1 value is 3 root 2. I am taking root 2 in common. Therefore, what will we get? 5 minus 3 root 2. Within the brackets, if we solve 5 minus 3, it is 2. So, 2 into root 2. Next, we will find T3 minus T2. T3 minus T2 in the sense 7 root 2 minus T2 value is 5 root 2. Again, I am taking root 2 in common. 7 minus 5. 7 minus 5, it is 2 into root 2. We will move on to the next portion. T4 minus T3. T4 value is 9 root 2 minus T3 value is 7 root 2. Again we will take root 2 in common. We will get 9 minus 7. 9 minus 7 is 2 into root 2. If you see in this problem, the difference between any two consecutive numbers is the same, that is 2 root 2. Therefore, the given above sequence 3 root 2, 5 root 2, 7 root 2 9 root 2 are in AP. Next is example 2.24. In this problem, we have to write an AP. To write an AP, we are given with the first term as 20 and the common difference given is 8. This is so easy to do. So, what is an AP according to the definition? A plus D, A plus 2D, A plus 3D, it goes on, etc. So, to write this, we are given with two values, that is first term is 20. First term is represented as A, therefore A equals to 20 and the common difference is given as 8. We denote the common difference as D, which is given as 8. So, we will substitute the value of A and D in the above sequence. We can write the AP for the given two values. So, first it is given as A value as 20. Therefore, 20 comma A plus D in the sense 20 plus 8. Next is A value is 20 plus 2 into 8 comma A value is 20 plus 3 into 8 etc. It goes on. So, 20 plus 8 is 28, 20 plus 2 8s are 16, 20 plus 3 8s are 24 etc. It goes on. So, 20, 28, 20 plus 16 it is 36, 20 plus 24 it is 44. So, thus we have written the AP for the above problem. In example 2.25, we have to find the 15th term, 24th term and we have to write the nth term, that is general term. To do these three things, we are given with the AP 3, 15, 27, 39 etc. It goes on. So, now what we have to do is we have to find the 15th term, 24th term and the nth term. So, let us write the values of A and D with the sequence given. So, A value is nothing but 3, which is the first term of the sequence, and to find the D value we can use the formula second term minus first term, that is T2 minus T1. T2 value is 15 minus T1 value is 3. So, 15 minus 3 it is 12. So, the common difference between any two consecutive numbers is 12. Therefore, D value for this problem is 12. So, we know the values of A and D now. Let us find the 15th term. So, to find the 15th term, we will use the nth term formula as I already told you, A plus n minus 1 into D. This is the formula for finding the nth term. We will take this formula. In place of n, if we substitute 15, we will get the 15th term. So, for finding T15, we are substituting n is equals to 15 and we know the value of A from the sequence which is 3 plus n value is 15 minus 1 into D value also from the sequence we got it as 12. Therefore, T15 is equals to 3 plus 15 minus 1, 14 into 12. So, only after simplifying this we can add it with the number 3. So, to simplify this, 14 into 12, 2 4s are 8, 2 1s are 2, 1 4s are 4, 1 1s are 1, 8, 6, 1. So, 3 plus 168, therefore, T15 is equals to 168 plus 3 it is 171. Thus, we have found the 15th term. The 15th term of this sequence will be 171, which we directly found using the formula. Similarly, using the same steps, we will find T24. So, to find T24, we will use the same nth term, Tn is equals to A plus n minus 1 into D. To find the 24th term, in place of n, we have to substitute 24. Therefore, T24 is equals to A value according to the given sequence, it is 3 plus n minus 1, which is 24 minus 1, and the D value according to the sequence, it is 12. So, 3 plus 24 minus 1 it is 23 into 12. First we have to multiply these two terms, then we have to add it with 3. 23 into 12, 2 3s are 6, 2 2s are 4, 1 3s are 3, 1 into 2, 2, 6, 7, 2. So, 3 plus 276. 276 plus 3 it is 279. Therefore, 24th term of the above sequence is 279. So, to find the nth term of the sequence, what am I going to do is we will consider the same Tn. Tn is equals to a plus n minus 1 into d. To find the nth term in this formula, we can substitute the a value and d value which is known to us. Therefore, Tn is equals to a value is 3 plus n minus 1 into d value is 12. So, simplifying this I will get 3 plus 12 into n, 12n minus 12 into 1, 12. 12n, 11 minus 3 it is 9. Therefore, Tn, that is nth term of the given sequence is 12n minus 9. Next is we are going to see how to find the number of terms in an AP. The number of terms in an AP could be found when it has an number of terms in an AP could be found in a finite AP, whereas A is the first term and the last term is represented as L and D is represented as a common difference. So, we know the formula for the nth term which is Tn equals to a plus n minus 1 into d. I told it is an finite AP. So, in a finite AP, we will know the last term, whereas Tn is replaced as L since we know the last term of the sequence. Therefore, we are replacing Tn as L. A is the first term, n minus 1 into d. So, from this we can bring the value of n. So, if I take the a to the other side, it will become L minus a equals to n minus 1 into d. On the right side, d is in multiplication. If we bring it to the left side, it will come to the division. Therefore, it will become L minus a by d which is equals to n minus 1. I want only the value of n. So, we are taking minus 1 to the other side, it will become plus 1. L minus a by d plus 1 equals to n. Therefore, when we are asked to find the number of terms in an AP, we can use the formula n is equals to L minus a by d plus 1. So, in example 2.26, we have to find the number of terms in the AP. Okay, so as I already told you, we can find only the number of terms in a finite AP. This AP is finite because we have a first term as well as the last term. We don't know the terms in between. We have to find how many terms will be there in an AP. Okay, let us use the formula and find. So, we have to use the formula n is equals to L minus a by d plus 1 in order to find the number of terms in an AP. We know the values of a, d and L in the above sequence. What will be the value of a? Value of a is 3 because the first term of the sequence it is 3. Next, the value of L is last term of the sequence which is 111 and we have to write the d value. D value can be found by using T2 minus T1. T2 value is 6 and T1 value is 3. Therefore, d equals to 6 minus 3, 3. The difference between any two consecutive numbers will be 3. Next, we will substitute these values in the formula. We can find the number of terms in an AP. Therefore, n is equals to L value is 111 minus a value is 3 by d value is also 3 plus 1. N equals to 111 minus 3 is 108 by 3 plus 1. 108 when it is divided by 3, 3 3s are 9, 1 8, 6 3s are 18. So, 108 by 3 is 36 plus 1, n is equals to 37. So, there are 37 terms in this AP. Next is example 2.27. In this we have to find the general term of an AP. General term is we have to find the Tn value. To find the Tn, we are given with two things. One is 7th term is minus 1 and 16th term is 17. With the help of these two hints, we can find the general term of an AP. Let us see how to do that. So, we are given with two hints. What are they? 7th term is minus 1. 7th term is represented as T7, which is minus 1. So, T7, that is Tn formula is A plus n minus 1 into d. If it is 7, we can substitute the value of n as 7 on the right hand side also. Therefore, a plus 7 minus 1 into d, which is equals to minus 1, a plus 6d, which is equals to minus 1. Let us consider this as an equation 1, and we are also given with the other hint, which is 16th term is 17. Therefore, T16 is equals to 17. Similarly, for T16 also we can use the same formula, and in place of n we have to substitute 16. Therefore, a plus 16 minus 1 into d, which is equals to 17. A plus 15d equals to 17. This we will consider it as equation 2. If we solve the equations 1 and 2 by linear equation method, we can arrive at the values of a and d, and it will be easier for us to find the general term of an AP. Let us do so. A plus 6d equals to minus 1. A plus 15d equals to 17. So, now we are going to solve these two equations and get the values of A and D. We will change the signs because they have the same signs, it cannot be get cancelled. So, we will change the signs. If it is minus, we have to change it to plus. If it is plus, we have to change it to minus. So, therefore, plus A and minus A will directly get cancelled. Minus 15 plus 6, it is minus 9D, which is equals to minus minus. We have to add the two numbers and have to put the sign of the biggest number, minus 18. So, minus minus will get cancelled. D equals to 18 by 9, D equals to 2. So, we have found the value of D. With the help of this D equals to 2, substituting in any one of these two equations, we can get the value of A. I will substitute D equals to 2 in equation 1. What is our equation 1? A plus 6d equals to minus 1. Therefore, A plus 6 into d value is 2, which is equals to minus 1. A plus 12 equals to minus 1. A equals to minus 1 plus 12. If it goes to the other side, it will become minus 12. A equals to minus 13. So, we have found the values of A and D, and with the help of these, we can find the general term of an AP for the given problem. So, to find the general term, the nth term formula is A plus n minus 1 into d. The value of A, we found it as minus 13. Therefore, Tn is equals to minus 13 plus n minus 1 into d value, we found it as 2. I am substituting it. So, next step is minus 13 plus 2n minus 2. So, we have to simplify this. 2n minus 13 minus 2 is minus 15. Therefore, the nth term Tn is equals to 2n minus 15.